निर्माण नो अभिगम कल्याण हो छात्र नो हरदम उच्च अभ्यास नो शिक्षण धाम महर्षि गुरुकुल महर्षि गुरुकुल महर्षि गुरुकुल महर्षि गुरुकुल महर्षि गुरुकुल.
Hello students, in this session we will be continuing with the introduction and solution of exercise 2.3 of chapter 2 polynomials from class 9 NCERT mathematics. In the previous section of the introduction we have learned how to divide a polynomial by a polynomial. And in this session, we will be moving further with the introduction part, that is what is remainder theorem, and then we will be dealing with the solution of exercise 2.3. Remainder theorem. In the process of division, that is we were dividing a polynomial p of x by g of x, we obtained the quotient q of x. We also obtained the remainder r of x by long division method. That is what we call it as long division method. Here, when p of x is given to you, g of x is given to you, and you need to find r of x, only the remainder. We are not interested in the quotient part. We are interested in the remainder only. Then remainder theorem plays a very important role. Here, we don't have to move for long division process to get the remainder, but we can get directly the remainder using the remainder theorem. Then what is remainder theorem? How remainder theorem helps us to find the remainder when a polynomial p of x is divided by another polynomial g of x. So let us see what is the theorem. Let p of x be any polynomial of degree greater than or equals to 1. We are given with a polynomial p of x. Here, the variable that is used should have a degree greater than 1 or equals to 1. Now, greater than 1 or equals to 1. Why not 0? Because a 0 is always a constant. Suppose we say 5 to the power 0, this is a 5. This is a constant polynomial with the degree of x to be 0. And if it is to be divided by another polynomial, this becomes a simple division. The algebraic division lapses somehow. So here, at least the degree of the variable that is used should be 1. Greater than 1 is also allowed. But less than 1, degree 0 is not allowed. So we are not allowed with degree 0. So at least 1. You can say, suppose we can take an example, x square plus 2. This is a polynomial with degree greater than 1. Suppose we are given with this. Moving on to again the definition. Let p of x be any polynomial of degree greater than or equals to 1, and let a be any real number. Any real number. It can be a rational number, it can be a irrational number. A, it's a value. A real number value. Say 2. Suppose this is a number, that is a. Then how it is applied? That is, if p of x is divided by the linear polynomial x minus a, if p of x is divided by a linear polynomial x minus a, what we had taken a, that is 2. Then if this is divided by the polynomial x minus 2, as the theorem goes on, that if p of x is divided by x minus 2, where a is a real number, a positive or a negative, that is up to us. Then the remainder is p of a. Then the remainder of this polynomial, when it is divided by this, and then remainder is p of q, the number that we have taken. That means if we are given with a polynomial with degree greater than 1, 2 is any real number such that x minus 2 is the polynomial with which p of x is to be divided. So this can be considered as our divisor, that is g of x. Now when p of x is divided by g of x, we get p of 2 to be the remainder directly. How do we get p of 2? If we did consider this number, suppose we haven't considered any real number, we are given with p of x, we are given with g of x, then how remainder can be found out? we will have to obtain the value of x for which the divisor g of x becomes 0. That means we are looking for the 0 of the polynomial for g of x. In other words, how can we do that? We can equate g of x to be 0 and obtain the value of x. Taking that value of x in the given polynomial, we get the remainder. This would be very clear to you if we move out with an example. The example goes this way. Example number 9, taken from the NCERT textbook. Find the remainder when this polynomial x to the power 4 plus x cubed minus 2x squared plus 1 is divided by x plus 1. That means this polynomial is divided by this polynomial. So if you observe, we are given with p of x, that is the polynomial x to the power 4 plus x cubed minus 2x squared plus x plus 1. And we have to divide this polynomial by this polynomial. That means we are given with g of x is equals to x plus 1. Now let us compare with the remainder theorem that is given to us. If p of x is divided by the linear polynomial, that is divisor is of degree 1. If p of x is divided by the linear polynomial g of x and that is given to us x minus a, then the remainder is p of a. Here this is x minus a form. What is the value of a here? That we will have to find out. And that value, when substituted in p of x, will give me the remainder for the given polynomial. So how do we find out that value a as per our remainder theorem? What we have to do is we have to directly equate the divisor into 0 to obtain the value of x. G of x is equals to 0. That means x plus 1 is equals to 0. So x is equals to minus 1. Comparing with our remainder theorem, this is the value of a. How do we get the value of a? By equating the divisor to be 0 and obtaining the value of x. Now what will be our remainder? The remainder will be our p of minus 1. The remainder is p of a. Our a here what we have got comparing there? Minus 1. That is the value of x. So if we substitute this value of x here, we get the remainder. So let us substitute and see. P of minus 1 is equals to minus 1 to the power 4 plus minus 1 to the power 3 minus 2 into minus 1 square plus minus 1 and plus 1. We have substituted. Solving whatever the value comes, that would be my remainder when p of x is divided by g of x. So minus 1 to the power 4, minus 1 into minus 1 into minus 1 into minus 1. So this is plus 1. Minus 1 cube, this is minus 1. And minus 1 square is plus 1 and plus 1 into minus 2 is minus 2. Plus into minus, minus 1 and plus 1. So this plus 1, minus 1 cancels, this minus 1, plus 1 cancels and we get minus 2. So this is the method how to obtain the remainder directly when one polynomial is divided by another polynomial using remainder theorem. The remainder can be found out by two different ways. One is directly by long division method, and secondly, if it is given that we need to find only the remainder, we can use the remainder theorem very easily to get the remainder. By long division process, we get quotient and remainder both, but by remainder theorem only, we get only the remainder and not the quotient. So we have to, whenever we are asked to find the remainder, only the remainder, the best method is to use the remainder theorem and not long division method, unless and until it is asked to do the long division method. Next example, example number 10. Check whether the polynomial q of t, this is the polynomial 4t cube plus 4t square minus t minus 1, is a multiple of 2t plus 1. Is a multiple of 2t plus 1. Multiple means, that means if it has a multiple of this, finally we should get something this. In general mathematics, what do you mean by multiple? That means suppose we are given a number 4. This 4 is a multiple of 2. Multiple of 2 means in the table of 2 we get 4. This is what in general we know. But how do we check it? If this number is divisible by this and the remainder is 0, we say it is a multiple. Many times we don't have to remember tables. How can we remember the tables of the algebraic expression, but there might be some method to check. So if we want to check that this 4 is a multiple of 2, that means this 4 is coming in the table of 2. We don't remember the table. We just divide the number by the given number, and if remainder becomes 0, then we say that this 4 is the multiple of 2. Similar is the case here. Q of t is a multiple of this. That means when this is divided by this, when Q of t is divided by 2t plus 1, if the remainder is 0, then we can say that this is a multiple of this. Other words, that word is many times they used here as factor. Prove that this is a factor of this. That means 2t plus 1 is a factor of qt. It is same. You can say factor, you can say multiple, everything is same if the remainder is 0. If the remainder becomes 0, then we can say that this g of t is a factor of q of t, or we can say that 2t plus 1 is a factor of q of t, or this is a multiple of this. Clear? Now let us move on. So we are given that q of t is equals to 4t cube plus 2t squared minus t minus 1. This is the polynomial that is given to us, and we have to divide it by, say, g of t. Let us take the name g of t, 2t plus 1. Now we have to check that qt is completely divisible by gt, then only we can say that this is a multiple of q of t. That means we need to substitute the value of t as per our remainder theorem. We know that g of t is equals to 0. So 2t plus 1 is equals to 0. So t is equals to minus 1 by 2. We have obtained the value of t. And on substituting this value of t in q of t, if the remainder is 0, that means we can say that q of t is a multiple of g of t. So let us find out the remainder using remainder theorem. So q of minus 1 by 2. We have obtained the value of t to be minus 1 by 2, and let us substitute there. So this is 4 into minus 1 by 2 whole cube plus 4 into minus 1 by 2 whole square minus minus 1 by 2 minus 1. So this is 4t cube plus 4t square minus t minus 1. Let us solve it. This is 4. Minus 1 by 2 whole cube. Minus 1 cube is minus 1 and 2 cube is 8. Plus 4 into minus 1 by 2 whole square. So minus 1 square is 1 by 4. So this is minus into minus plus 1 by 2 minus 1. We will have to just solve it and check out. This 4, 2s are again this 4, 4. So this is minus 1 by 2 plus 1 by 2 minus 1. So plus 1 minus 1 cancels, minus half and plus half cancels, and finally the remainder is 0. Applying the remainder theorem, we obtain the remainder to be 0. When the remainder is 0, then only we can say that the polynomial q of t is a multiple of 2t plus 1. So we can say that p of t is a multiple of g of t. And what was g of t? We took g of t as 2t plus 1. Let us move on to the exercise. Exercise 2.3. As I have told you that this is a session where we will be dealing with the introduction and solution also of exercise 2.3. So let us move on to exercise. The question number 1 goes on this way. Find the remainder when x cube plus 3x square plus 3x plus 1 is divided by x minus half, x plus 5 and 5 plus 2x. Actually there are 5 bits in the question and we have taken 3 bits out here and the 2 is for your practice purpose. So moving on to the question once again. Find the remainder when this is divided by this. So we are given with p of x. And what is p of x? X cube plus 3x square plus 3x plus 1. And this polynomial is divided by x minus half. So we are given with g of x is equals to x minus half. We will be finding the remainder using remainder theorem. So for using remainder theorem, the first thing that we need is the value of x, which we will be substituting in p of x to get the remainder. That value of x will be obtained from g of x. So let us take g of x is equals to 0 and obtain the value of x. So x minus half is equals to 0, x is equals to 1 by 2. We have now got the value of x. Substituting this value of x in the given polynomial, we get the remainder as per the remainder theorem we have seen in examples. So let us get the remainder. P of half is, substitute everywhere, half cube plus 3 into half square plus 3 into half plus 1. So let us solve this. 1 by 2 cube is 1 by 8 plus 1 by 2 whole square is 1 by 4 into 3 is 3 by 4 plus 3 into 1 by 2 is 3 by 2 plus 1. And we will have to solve it by taking LCM. And what is the LCM? This is 8. 1 plus 6, 4 2s are, so 2 3s are 6, 2 4s are, that means 12, and plus 8. And finally, we get as 27 by 8. So 27 by 8 is the remainder that we are looking for. Same method that we have done in examples. First of all, we took gx of x to be 0. We obtained the value of x and substituted this value of x in the given polynomial and solving, we get the remainder. Here in this case, we took 27 by 8 is the remainder. Moving on to bit 4. Now we are given with g of x is equals to x plus pi. And we will be getting the value of x from here and we will be substituting on p of x. To get the value of x, let us consider g of x equals to 0. That means x plus pi is equals to 0 and x is equals to minus pi. We don't have to put the value of pi, 22 by 7. It's not necessary. So x is equals to minus pi. Now we are given with our polynomial p of x is x cubed plus 3x square plus 3x plus 1. This is the polynomial that is given to us. We need to find the remainder when this p of x is divided by g of x. So by using remainder theorem, we will substitute the value of x in p of x. So this is p of minus pi. This is minus pi whole cube plus 3 into minus pi whole square plus 3 into minus pi plus 1. Everywhere wherever there is x, we substitute the value minus pi. Let us solve it. Minus pi whole cube is minus pi cube plus minus pi whole square is pi square into 3 is 3 pi square. 3 into minus pi is minus 3 pi plus 1. If you want to simplify it, you can put the value of pi to be 22 by 7, else you can keep this way. Since there are no like terms, so no simplification is required. Everywhere the degree of pi is different. So this is the final remainder that we get when the polynomial p of x, x cubed plus 3x square plus 3x plus 1 is divided by x plus pi. Moving on to the last bit that we are in. We are given with g of x is equals to 5 plus 2x. For applying the remainder theorem, we need the value of x to be substituted in p of x. So let us take g of x to be 0 to get the value of x. So 5 plus 2x is equals to 0. So 2x is equals to minus 5 and x is equals to minus 5 by 2. This is the value that we have got for x, and this value is to be substituted in the polynomial to get the remainder using remainder theorem. So let us find. This is p of minus 5 by 2 substituted in the polynomial. What was the polynomial? X cube. That means here this is minus 5 by 2 whole cube plus 3x square. That means minus 5 by 2 whole square plus 3x. So 3 into minus 5 by 2 and plus 1. So this is plus 1. So let us solve it and get the remainder. So minus 5 by 2 whole cube is minus 125 by 8 cubing it plus minus 5 by 2 whole square is 25 by 4 into 3 is 75 by 4. This is minus 15 by 2 plus 1. Taking the LCM and simplifying, the LCM is 8. So 8 ones are, so this is minus 125 plus 4 twos are, so that 2 is multiplied with 75, it becomes 150. Then 2 fours are 8, so we are getting 4 as a multiple, so 4 into minus 15 is minus 60, plus this is 1 upon 1, 8 are, so this is 8. So let us solve it. Minus 125 plus 150, that is 25, 25 minus 60 is minus 35 and plus 8 minus 27. So this is finally we have got the remainder to be minus 27 by. This is how we can find the remainder in question number 1. Question number 2. Find the remainder where x cube minus ax square plus 6x minus a is divided by x minus a. We need to find the remainder. We are asked to find the remainder. I have told you that when it is asked only to find the remainder, move on with the remainder theorem only and not by log division method. So for that, to find the remainder using remainder theorem, we are given with p of x. And the p of x is x cube minus ax square plus 6x minus a. And this p of x is divided by x minus a. So we are also given with g of x. That is x minus a. And in order to find the remainder, we should get the value of x from gx and substitute that value in p of x to get the remainder. So let us get the value of x by taking g of x to be 0. G of x is 0 means x minus a is 0. So x is equal to a. The value of x is a. And we will get the remainder by putting this value of x is equal to a in the given polynomial. So let us get the remainder p of a. So everywhere wherever we have x, we have to substitute a, the value of x. So this is a cube minus a into a square plus 6 into a minus a. So we have substituted the value a. Let us simplify it. This is a cube, a square into a is minus a cube plus 6a minus a. So a cube minus a cube 0 and 6a minus a is 5a. So this is finally the remainder that we have got when p of x is divided by g of x. Moving on to question number 3. Check whether 7 plus 3x is a factor of 3x cube plus 7x. We have discussed right now factor and multiple. What we have discussed, that if p of x is divided by g of x, if remainder is 0, then only we can say that g of x is the factor of p of x. That means what we are looking for? We are looking for remainder to be 0. So let us move on with the remainder theorem. It will be easy to check. It will be easy to find out what is the remainder. So we are given here with p of x is equals to 3x cubed plus 7x. We are also given with g of x is equals to 7 plus 3x. We need to find the value of x from g of x, and that value of x is to be substituted in p of x to get the remainder. If remainder is 0, then we can say g of x is a factor of p of x, else not. So let us find the remainder first. And for the remainder, let us take g of x is equals to 0 to get the value of x. So g of x was 7 plus 3x, and that is equals to 0. So 3x is equals to minus 7, x is equals to minus 7 by 3. So we have obtained the value of x, and let us find the remainder substituting this value in p of x. So this p of minus 7 by 3 is equals to 3 into minus 7 by 3 whole cube plus 7 into minus 7 upon 3. Now simplifying, if we get 0, then only factor that's out. So let us find the remainder. So 3 into minus 7 whole cube, that is 343 by 27. This is minus 343 by 27 plus this is minus 49 by 3. So let us multiply 3 here also. This is 9 to 1 and 1029 minus 1029 by 27 plus into minus is minus 49 by 3. Let us solve it by taking LCM. So this is LCM is 27. This is minus 1029 minus this is 3 so 49 into 3 is 147 and simplify it. So this is equals to minus 61 7 1176 by 27 which is not equals to 0. We wanted the remainder to be 0. We were asked to check whether this is a factor of this or not, and we haven't received the remainder to be 0. So we can say that g of x that is given to us, g of x is not the factor of the given p of x. So this way we can check whether a particular polynomial is a factor of the other polynomial, whether a polynomial is a multiple of the other polynomial. We can also find out the remainder when one polynomial is divided by another polynomial by remainder theorem, and we can also divide a polynomial by a polynomial in order to get the quotient and remainder to satisfy the division algorithm.